In this quick video, let's try to solve this problem here. Let's try to find the first derivative of y with respect to x of this function right here. Y is equal to x to the 2 to the x. Now, the first thing to do is to take note of the one of the most important rule in logarithm, the power rule. And the power rule says that the natural logarithm of any power function x to the p is equal to the product of the exponent p times the natural logarithm of x. Now, this is the power rule, and remember this because we're going to use this much in finding the derivative of y with respect to x. Now, to find the derivative of y with respect to x, let's apply the natural logarithm of the both sides of the equation. The natural logarithm of y must be equal to the natural logarithm of this function in the right hand side, x to the 2 to the x. Now, we have this in this form, and our p here is just this 2 to the x. So, we'll have to bring this down here and multiply ln of x. Now, the next step is to take the derivative of both sides by implicit differentiation. The derivative of ln y is just 1 over y times dy over dx is equal to the derivative of this expression here in our right hand side is with respect to x is just done by product rule, and a product rule says that the derivative of that expression is 2 to the x times the derivative of ln x with respect to x plus the ln x times the derivative of 2 to the x with respect to x. Now, before proceeding, let's try to take this first, the derivative of 2 to the x with respect to x, since we're gonna apply again this formula here. Let's try to let the 2 to the x be w. Let w is equal to 2 to the x, and we'll try to apply this here. Let's take the natural logarithm of both sides of the equation. Ln of w is equal to ln of 2 to the x. Now, again, this is our p here, and we'll bring this down here, our x, ln of 2. Now, taking the derivative with respect to x by implicit differentiation, we have 1 over w dw over dx is equal to the derivative of the right hand side is just the constant ln of 2 because the derivative of x is just 1. That, and then multiplying w to both sides of the equation to cancel this here. We have dw over dx is, now remember our w is just this here. Our w is 2 to the x. That's why we'll write it down here. 2 to the x times this ln of 2. Now this is the derivative of 2 to the x with respect to x. We have 2 to the x times ln of 2, and we'll plug that in here, and let's proceed with our problem here. We have 1 over y times dy over dx is equal to 2 to the x times the derivative of ln of x with respect to x is just 1 over x plus ln of x times the derivative of 2 to the x with respect to x is here, this. Let's plug that in here, 2 to the x times ln of 2. Now, multiplying y to both sides of the equation to cancel the y in our left-hand side expression. And we're left with dy over dx is equal to the quantity or the expression or the function y. Let's substitute our y, x to the 2 to the x times this whole expression here inside our bracket. 2 to the x over x, this is from here, plus 2 to the x ln of x times ln of 2. Now, this is our final answer. And that's all.